commodities outlook. In the end, we make 20-year predictions on commodity prices. We call it science by converting it into bankable feasibility studies. We are so, the only thing we know for sure is that the view we take will be wrong. You know? So if we are really smart, then we get the trend right, or we get the big picture right, or we get the first few years right. And having said all of that, there's not a way in the world that you can raise money, or spend your own money, or commit to a 20-year project without taking a view. And so I think at the start of the day, it's perhaps very important for us to have a conversation about what are the views out there. So Robin Griffin is joining us online. He's been patiently waiting for about 2 hours, I think, Robin. We are going to give Robin a chance to make a presentation, and then there will be a few minutes to put questions to him. Those are the questions you're going to send through to me on the platform now. So Robin, thank you very much. You know, Wood Mackenzie doesn't need introduction. I don't think you need introduction, but we are really looking forward to your views on commodities beyond 2023. Over to you. Thank you very much.
Thank you, Bernard, and hello, everyone. I hope you can hear me okay. Let me know if you can't. Yeah, no, it's a pleasure to be joining you from Brisbane for today's session. I thought that I would kick off with a more thematic discussion about metals markets and mined commodity markets, and specifically their role in the energy transition, looking basically over the next decade and beyond. And I think Willis in the next session is going to talk a little bit more about detail within specific markets. But I hope it's relatively high level pitch, and I hope it can raise some interesting points of interest. And this is the first and last marketing slide, I apologize, but what I wanted to show this for is the bottom row is showing a number of value chains, verticals, if you want to call them that, that we cover at Wood Mackenzie. But they are all, of course, important, or the vast majority of these are very important in terms of the energy transition. And when we look across power, electric vehicles, hydrogen, carbon capture, etc., all of those verticals rely on the timely and economic supply of metals. And things like hydrogen, we think will actually be stymied or constrained by the supply of things like iridium, for instance, over this decade, perhaps not as you move forward. But we do think that metal supply is going to be a rate determining step for the energy transition. That's quite important, we think. Part of the reason is because the energy transition is so metals intensive. And if you look at coal-fired power stations, they use about 2.5 tons of metals per megawatt. For solar, it's 7. For offshore wind, it's about 15. EVs use something like 8 times the metal of an ICE overall, and up to 3.5 times the copper, we think, depending on the size of the battery. So it's great news for metals. And if you look at the sort of growth rates, at least what we're forecasting in our base case, there really isn't a bad story for metals. The narratives are very positive across the board. In fact, the growth rates over the rest of this decade we expect to be higher for base metals and battery raw materials than they have been over their sort of 30-year average. And you can see in battery raw materials and nickel how the energy transition is kind of skewing the growth rates towards those commodities that go into the EV supply chain. The growth rates are large. Lithium's, we're looking even this decade at almost quadrupling. So obviously, certainly a hot commodity, despite some of the issues around prices over the last few months. And nickel, of course, is the standout of the base metals, but even copper aluminium. They're looking at 20% growth over this period. The other side of the coin is, of course, bulk commodities, and I guess I can make a few comments on that as we move through. But iron ore is not really about the energy transition as such. I mean, there is an impact on iron ore, but it's not huge. Most of that reduction that you're seeing on that slide over the next decade is China's structural decline for steel demand. And that's going to start at some point. Identifying when is a problem. And of course, thermal coal, I suppose, is a little bit more understandable, given that's, the issues around emissions from fossil fuels. So the outlook is good. I mean, I guess we can put some numbers on it just to give you an idea of scale. But if you look at the right-hand chart first, copper, we're looking at about 5.5 million tons of market growth. That's a market, that's primary demand, so from mined metal. That's a market that's producing something like 22 million tons from mines at the moment, another 8 million tons from scrap. So pretty big numbers. Lithium, you're looking at 1.5 million tons, a market that's only 700,000 tons today. So it's pretty huge. Interesting to know, obviously, that the amount of material that needs to be mined and moved as a result of these sort of future-facing commodities, let's call them, is obviously much lower than bulk commodities. And you've got the other side of the coin on the left-hand side. Aluminium is going to grow substantially, 13 million tons or something, but probably only going to need about 80 million bank cubic meters of material moved. The hard coking coal seaborne trade every year needs about 2.4 billion tons of bank cubic meters moved. So the falls that you see in iron ore, for instance, particularly thermal coal, are going to offset the gains. Anyway, not necessarily something for miners to worry about too much, but service providers certainly giving that quite a bit of thought. So that's sort of growth, but it's obviously more interesting to look at how we think supply is going to respond to that demand growth. And I've just gone out a few years here to look at the 10-year forecast. And all I've done on the left-hand chart is really compare what our demand is under our base case and compare that with commitments made by miners in various commodity markets. And so what you're seeing there, if it's a negative number, it basically means there aren't enough projects that have been committed through this period to actually meet our demand forecast. And the numbers are pretty big. For copper, it's 6.5 million tons, something of that order. For lithium, it's basically 1 million tons. So these are really big numbers. Now, it doesn't mean that we're going to have that deficit. It just means that we need to accelerate the investment in order. We've got to make decisions basically as quickly as we possibly can that allow us to accelerate the supply to meet this demand. A quick note on the peak demand raw materials, so the bulk commodities. Iron ore and thermal coal, we saw in the last slide. We think there's probably going to be enough of that material, but the numbers aren't huge because investment rates have been so poor, particularly in thermal coal, that there's still a risk that thermal coal could be short over this period, even though we're expecting demand to fall. And because India is growing so fast for coking coal demand, we don't think that there's going to be enough projects around by this time, or at least more work needs to be done. One of the problems is that we're not seeing the response that we think is required to meet this, this need for a surge in supply. And this chart is just looking at the capital expenditure guidance from the sort of five majors, diversified miners. Capital expenditure for growth is actually increasing. That's showing on the left-hand chart. So it has started to move. If I had compared it to 2012, 2013, there really is a huge difference, though. That was the peak. But at least things are kind of moving in the right direction. The problem is more capital's being spent. The right-hand chart is just trying to give an idea of what proportion that growth capital is compared to overall capital expenditure. What we're seeing now is obviously a lot of capital is being diverted to decarbonisation. And we know miners are having difficulty getting capital put into growth projects because they're providing that back to shareholders. That is an ongoing issue. But now, of course, they've got the additional capital around decarb. So that's not helping this potential for a deficit. The other thing to say is, I'm sorry, this is a little bit too much on this chart, but the next few years we are expecting to see markets soften generally, just from a fundamentals perspective. So this chart is essentially just showing supply of various commodities minus their consumption. So above, if the arrow ends above the line, you're looking at a market in surplus. Most markets are going to be sort of in balance or you know, a very, very modest surplus. Most of them are moving from a period in 2021, 22 when they were in deficit. On the whole, a lot of uncertainty at the moment, but on the whole, over the next 2 to 3 years, we think there is a loosening trend which will result in prices softening. Not talking about prices collapsing, just talking about prices softening. Margins will still be good, but we're asking for this additional investment into markets that are essentially softening in the period through to 2025, 26. Once you get beyond that, markets start to tighten again, and we should start to see sort of higher price signals again. The reason that's important is because it takes so long to develop mines. I don't need to tell you that because you're living it every day. But we need the investment now, and this is just showing kind of there is an average development time frame based on database of projects that we hold. You know, for copper, you're 10, 12 years. From first discovery, and the ramp up we've got there 3 years is pretty aggressive for some copper mines. So we need decisions quickly. There doesn't look like they're coming, at least in the period to 2030. That's going to be an issue because you know, if you're making a decision now, you're really only going to get first production in 2030 anyway. Lithium looks fast because a lot of those Australian mines came on quite quickly after the 2019 downturn, but we think that's going to get harder too for new mineral lithium deposits, and I'm sure Africa development will be longer than that, 4 years. Nickel might surprise us. We know we've got some HPALs that have come on the last few years at sort of 4 years, but they have relied on existing infrastructure in those large industrial complexes. So it's gonna be an issue. And that, so I mean, we cannot see that there is a problem with supply meeting demand even under our base case, and our base case is consistent with a warming potential of about 2.5 degrees, right? So it's not, I mean, we haven't chosen 2.5 degrees, but when we add up all of the emissions from all of our forecasts, it's equivalent to about a 2.5 degree warming. So we're way off where the most aggressive Paris targets are. And this chart is just showing the difference between our base case, which I don't know if you can see my cursor, but it is that top line, and the 1.5 case is the bottom line. And we've just filled it in with those sectors that will need to reduce emissions, and power and transport are huge parts of that. It's a huge opportunity. It's $60 trillion of investment. About 20 trillion of that is associated with transport and power. But we're talking a huge ask. Brilliant for metals, of course. As I've said, just to give you an idea on the additional challenge, this is just looking at power supply between what I'm calling our base case, which is called ETO in this chart, and 1.5 degree case, which is the very, very strict Paris case. You can see that wind and solar under the base case, the light blue line, are growing very, very rapidly anyway. But then you have to essentially double or triple that growth in power supply in order to get to the 1.5. You've got to rely on hydrogen in a big way into power. You've got to rely on bioenergy, geothermal, and nuclear has to play a big role. They're just isn't the capacity in other parts of the system to allow this to happen. So it's a monumental task in itself, and obviously has quite a big impact on the amount of extra metals we're going to need. For EVs, just to give you an idea of the difference, under our base case, we're looking at a very large increase in electric vehicles, 35% penetration by 2030. That's about 40 million vehicles. I think 11 and a half were built last year. So it's a huge growth anyway, but to get on the 1.5 degree path, you're looking at about 70 million vehicles, essentially. So an extra 30 million vehicles by that time. I mean, some people think it's doable. We think it's pretty tough. We can see quite a lot of manufacturing capacity available, 4,000 gigawatt hours worth lithium ion alone that's in our database. We don't think that'll all come on, but we probably need 6.5, 7 to actually get on target for Paris. So the actual target itself is difficult. We don't think it's going to happen, partly because we don't think there's going to be sufficient metals. And this chart is just showing it's essentially the same chart I showed in the light blue, which is the gap under our base case, but then I've just shown the extra gap under the AET 1.5, as we call it. That's that 1.5 degree. So you need an extra 2 million tons of copper. You need an extra 5 million tons of aluminium. You need an extra 1.5 million tons of nickel, for instance. And that's on top of everything else. And to get there, obviously, we're going to need a pretty rapid increase in investment. And if we actually look at all of the projects that we're following across all of metals and mining, investment rates are actually declining. And this chart in the light blue is showing what we've what we've got in our database at the moment, when projects we think are coming on and have capital committed. It's falling gradually. If we remove the iron ore and met coal, it would actually fall much more rapidly. So metals, those commitments are actually slower, about 70% reduction over the next 5 years. I mean, it's a reasonable amount of money being spent, but in the dark blue, we're looking at what we think would need to be invested to actually meet the faster 1.5 degree target. Copper actually looks quite good over the next 3 or 4 years. It's the project pipeline is as good as it's been in the last decade, but it's still insufficient once you start looking at 10 years to meet the kind of levels we need. We have invested 27 billion in copper in the past in a single year, but we've never done it every year for a decade, and nor have we done it every year for 30 years, which is essentially what we're going to need to do in order to meet these broader targets. One of the problems is actually there is an acceleration in the need for supply between 2030 and 2040. That's probably unsurprising, but that's the decade where EV penetration and the power transformation, renewables penetration is at its greatest, and that's when we need the most metals. So the gaps that I've been showing you to 2030 are actually greater by the time we get to 2040, before there's a modest slowdown in the subsequent period as the EV market gets essentially saturated. Copper is way out in front, as you can see. I mean, this is our estimate, 700 billion of 1.2 trillion that we think needs to be invested in mines over that period. But copper is obviously by far and away the biggest. And so really, I mean, the numbers are pretty huge for other metals as well. So we've either got to use more scrap, or we've got to design some of these metals out of the solutions, these low carbon solutions. Problem is with batteries, we don't have the supply of batteries yet to actually generate a market of recycled products. So we've got to wait, 11 or 12 years really is what we think. 11 years is probably an average for a battery. Car manufacturers are guaranteeing for 8 years, but you're going to have to wait for that time into the 2030s to get the response. Even when we start getting those batteries, there is a lot of technical issues to overcome, and the right-hand chart is just showing what we think is possible for recycling. We don't actually get above 50% for any of the battery raw materials, even the high-value stuff, cobalt, lithium, which are about 40% or so. Just on copper on scrap, there is the opportunity to actually produce a lot more copper, about 10 million tons more than we're currently forecasting by 2040. That would actually limit the amount of new copper from new copper mines that we would need. The problem is you've got to recycle 95% of absolutely every kilo of copper that exists or that comes to market at end of life, and some of those products are only 50% at the moment. So it's a huge ask, and that's without even constraining at the quality level. So I've only got a couple more slides. I'm not sure of my timing, but I may have taken too much time. So I mean, there are a number of issues around. We're not necessarily saying that we'll never meet the more aggressive Paris targets, but to 2030, it's almost impossible, we think, for us to be on a trajectory to the 1.5 degree world. Lots of things have to change. A couple of other things that are worth noting and could be a limit on that speed of the transition. One is China's domination of various parts of value chains for mined commodities. When it comes to batteries, I mean, hugely dominant, as you all know, in components and cells, 80% or so. Pretty much all of lithium chemicals, essentially, particularly the spodumene, is being turned into chemicals in China. It's really only the mining where there's a bit more, a little bit more diversity in terms of where the supply is coming from. But cobalt obviously is quite reliant on the DRC anyway. But there's Chinese investment in there. Nickel from Indonesia is quite fascinating in terms of the speed of that supply growth. But of course, that's also relied on Chinese investment, and there's questions about whether that will kind of meet the US IRA requirements, for electric vehicle tax concessions, etc. So China understands this and is kind of moving to move it to dominating positions in some of these as well. But the issue is if we're not buying from China, the transition will be slower. And if we are buying from China, there are broader implications about geopolitics, because at some point China has its own transition. They will leverage this hegemony, and they may, it has much broader implications than just mining. And just lastly, metals themselves are, of course, emitters. Aluminium can emit 20 tons of carbon dioxide equivalent per ton. Steel's about 2. Nickel is about 40 if you're using a coal-fired power generator RKEF process. And it has implications both to the total emissions. I mean, there's about 4 gigatons of emissions that come from mines, 4.5 or so. But eventually there's going to be carbon prices. There will be a global carbon price at some point. And that is going to have a broad range of effects. One of them is that it's obviously going to push up the price of products produced from those very high emitting processes. And so there are opportunities actually for low emitter producers, because they will inevitably be pushed down the cost curve. And so margin growth is one of the things that's, well, higher prices in general, of course, but also margin growth for those producers that are able to move down the emissions curve faster. I think that's me done. Apologies if I took a little bit more time, but happy to answer any questions you may have.
Robin, thank you very much. Thank you. I don't think anybody took the eyes of your slides. I want to reflect on your presentation in the words of Roy Kent from Ed Lasso. Fuck. I mean, it is just like fuck. And in my language, fuck means you're tired. But in, I think the way Roy Kent says it is the way I want to apply it here. Clearly, we have often heard that there's the disconnect between a narrative about energy transition and the green world and the mining and how it plays out. I think you've sort of captured it. Can I ask one question? Politicians then get involved and we get the IRA and that puts money to the manufacturing side further downstream and we get gigafactory announcements. And none of that has yet seemingly resulted in the policymakers and the politicians understanding the gap that may develop at a mining level. Am I speaking like a true miner, or would you share that view that the politicians come from the end, we need batteries, therefore we need gigafactories, but the mines aren't yet getting attention?
Yeah, no, totally agree. I mean, it's very easy to stand on a site and say we're going to build a gigafactory here, and the gigafactory, the actual, the factory itself can be built very quickly or relatively quickly. But when you look at the US, I mean, they've got a large a pipeline of gigafactories. They don't have the cathode manufacturing. They're absolutely short of the components that will be required to supply that gigafactory. And of course, they don't have the metals. And so, and as I showed, I mean, you've got those huge timelines. So you build a gigafactory in 3 years, but it's going to take you 10 or 12 to ultimately find the copper eventually, to fill them all. So yeah, I mean, that's a real and present danger. People are waking up to it, but it's slow, unfortunately. And I think it's only the Canadian critical minerals strategy that actually talks about changing policy to speed up mining development. Not Australia, not the EU, not the US. Pretty much no one is really implementing anything yet.
Yeah, and very much the purpose of our soon London Indaba, where we talk about this from an African perspective, is exactly, African is not a collective, but the African continent is not yet even talking about these sort of things in any recognizable shape or form. And we argue a lot of the mining could potentially come from Africa, so we want to try and start the conversation to close that gap. So I know you are staying online. I really appreciate. I also know you and Willis has colluded a bit, two competitors colluding, that his presentation will unpack some of the other aspects a bit further. And so quite a few of the questions is actually probably going to be answered. So if that's okay, I'm going to ask Willis to come and make his presentation. We'll revert back to the questions I have plus more at the end of the session. But thank you very much. Everybody took pictures. I do suspect I'm going to be allowed to share your slides. It's a bit of a moot point because, as I say, everybody took pictures of every single slide that's come on anyway. So we will make the slides available with the permission of Wood Mackenzie if it is given to us. So thank you for really a mind-blowing summary presentation. We will edit the proceedings and the recordings to take Roy Kent out of it, but everything else stands. I mean, it really was mind-blowing. Over to you. Will you come and give us your next presentation, or the next presentation, Willis? Thank you.
Well, thank you. Great presentation by Robin, and it really sets up very much what I'm going to be speaking about today, which is making the math, in my American English, or maths as other people will call it, work for critical minerals. And I think it's a really true thing that we're working on in CRU, and we're seeing a lot of questions about this. But I do want to start off with, one of the good comments in there is there was no disclaimer in Robin's slides, and my legal department did not get a hold of mine, so I also don't have a disclaimer here. So, this is our best view. This is, of course, a forecast. This is looking out into the future. So we're doing our best here, but don't take it as gospel. It's a view on the future. Also, my marketing team did not get a marketing slide in here, so I don't have my shameless plug, but if you see me after it, I'm happy to try to sell to you anything you'd like to buy. So no worries on that. We'll get through it together in that way. Okay? So again, I'm Willis Thomas. I'm actually the head of CRU Plus, which is a new offering inside of Crew, which is actually focused on junior miners and small projects. A lot of times, large consultancies don't have the time or bandwidth to work with smaller clients, and the budget on the other side really doesn't work out. So this is our first trip to the junior Indaba. We certainly intend to be in London with quite a few of my colleagues, as well as we regularly attend the major Indaba. But this is now my role, and I get to work with the supply side a lot more. Coming from the industry and working in solder before this, I know quite a bit about certain metals, and have expanded that knowledge through my time at Crew. So let's talk a little bit here. So this is sort of going over exactly what Robin was talking about there. The energy transition is really going to pool on a lot of critical commodities, many of which are represented by producers or potential producers in this room. And there's going to have to be a lot of movement between now and 2030, 2040, and 2050, rightly as Robin said. And there's actually nothing in his presentation that I could disagree with one bit, which is really good because colluding before this as competitors does help to make sure that the messages are about the same. And honestly, looking at many of these forecasts, they're not terribly different between companies because there's a lot of consensus on the demand side of where currently things are focused, but where also we need to be to get to about 1.5 degrees, because 2.5 is essentially the base case based on production today. However, there's going to be a lot of this rapid demand growth in the next couple years and the rest of the years to 2050 are going to really put a lot of pressure not only on the industry, but on policymakers, on people who are championing the industry, and those that are looking out for things like environmental, social, and governance aspects. So there's going to be quite a bit of change. You know, the conversations 10 years ago were not like this. The conversation even 2 years ago about electric vehicles was not talking these type of demand growth to 35% by 2030. That number keeps moving up as we see even some slowing in the automobiles today that through the rest of the 2020s, and even my 70-year-old parents are looking at their own first electric vehicle for the next one, and that's on a farm in the United States. So this is moving more quickly than I think any of us really expected. But there's definitely going to be some key challenges. The first one, rightly, as Robin points out, the geopolitical risk of where these minerals are going to come from is a big one. Certainly we saw in the recent CRMA from Europe that there is an expansion and an understanding that not everything can be mined in Europe. Clearly, not everything can be processed in Europe. So having some sort of quota system and having an idea of diversification is quite right. There are uncertainty in demand forecasts, of course, whether we see that for 1.5 or 2.5 degrees. However, we all know exactly what the direction is going to be here. It's just a magnitude question. So that uncertainty makes it difficult for financiers to put money into projects, especially around new metals that they don't understand. We've done a lot of work in vanadium recently, which is a relatively small market that needs to grow by 3 or 4 times by 2040, even if it only takes a small share of energy storage. That's a lot of speculation, and I was grilled for about 2 hours on Monday as my laptop was dying by some financiers trying to understand this very market, to understand if supply can meet it. Well, supply meeting the demand going in the future is up to the folks in this room and many other junior mining conferences around the world. We also know the population growth is going to be important, but it's going to be important where that population growth grows and what the quality of the urbanization for that population is going to be. That's very metals intensive if you have a very high quality or high income urbanization, but then it becomes quite low metals intensity. You see that in places like Santiago, Chile, which is relatively flat and very filled with concrete. That's not going to drive a whole lot of metals intensity for things like steel. We also know, and this is a big one here, as every dinner this week has been cut out at least one time through a power outage, energy supply is going to be a difficult question, not just here, not just in places that are developing, but in countries where they still have so much coal-fired power that no matter what you do from an aluminium perspective, on your own supply chain, your emissions are still going to be regulated significantly by the power that you have to get from the grid. And finally, we know that the impact of technology in some ways is going to help thrift. We know that it's going to help process things better and differently. We see that in the recycling of lithium-ion batteries. as more flotation techniques come in. Previously, using pyromet technology, you would burn off the anode. The graphite would be lost. Well, now there's chances to recover some of the graphite there. So this helps to close that supply gap. But at the end of the day, a supply gap is a theoretical thing. It does not exist in nature. So how do we close this gap? Well, it's going to have to take a team effort by policymakers, by the consumers, and by producers to actually get us to where we need to go. So let's talk a little bit here, and let's talk a little bit more about specific commodities. So you can see on the left-hand side of this chart that the material requirement for decarbonization of power and traffic is going to drive significant growth in terms of every one of these materials. And something that's interesting is previously we would not have thought of things like phosphate rock as something that was important, because 5 years ago, the LFP battery was looked at as something that was too cheap, not powerful enough, and would not last in this market. Yet today we know, even in such a large market, by 2027, about 2% of phosphate rock will actually end up going into batteries. And that's with LFPs essentially holding their share of the market in many different places. But for many other of the commodities, they're going to rise from very small percentages of the market being into any type of battery or technology solution to a significant portion. Of course, I have been the vanadium expert at Crew for quite a long time, so it is my favorite market. And going from 1% of the market, give or take, in 2020 to over 30% of the market is really truly about the story of vanadium going from a ferroalloying metal with technology applications to a technology metal with some ferroalloying applications. And by 2040, it's going to be about 60 to 75% of vanadium will be used in battery storage. And that's taking an extremely small portion of the long duration storage that is needed, just to balance out the grid and to incorporate variable renewable energy. That still doesn't account for the grid stabilization that is needed in places like South Africa, as well as other developing countries that need variable renewable energy type batteries right now just to balance the grid as it is. So there's both the quality of power that needs to rise in certain places, but also then integration of variable renewable energy. So this is going to drive quite a bit of change in almost every market we see here. And some of these are quite large. Copper being such a large market already, going to 14% of it being involved in sort of decarbonization is going to be a massive change for the market. And we saw in Robin's slide how much money that's going to take. And that's true. There's no doubt about it. This is going to take an unprecedented amount of capital to bridge these gaps that we see into the future. And that's not just in large markets, but it's in small ones too. It's going to take very specific financiers that are willing to take the risk on markets like vanadium, markets like rare earths, which is so small that most banks are not interested in the market capitalization that's available in rare earths, even if it's going to be something that grows significantly. And that's been quite a challenge in terms of getting money. That money is now more expensive than it was 2 years ago. So these all become challenges in reaching these significant demand figures. And this is only by 2027. It's 4 years away. I mean, that's not that far. Now, and we're speaking about how much these will change by 2050 or 2040. That's going to be quite the change. So looking at just 4 different commodities here over the next 7 years, or 4 years, excuse me, we have up here, I brought the laser pointer, lithium, cobalt, aluminium, and nickel. So all of them we can see here with the demand line in our mustard yellow, which I don't particularly care for, but I hope you can see it well. We can see that in the middle of this decade, we'll actually have a slight surplus in some of these metals. And so while the markets certainly aren't going to crash, and we'll talk about pricing here in a second, this type of environment makes it somewhat difficult to finance. Because you're not seeing peak prices today. Peak prices are in the past, when there was definitely a deficit. You can see that in 2022 in almost every market, there was a deficit. And for aluminium, even a small one means a big difference, okay? And aluminum prices are certainly going to have to be higher into the future because of structural support from costs. But many of these others are going to see some moderation in pricing, which will make financing even more difficult. But if we were to expand any of our pricing outlooks out into the 2030s in this, these certainly have to rise, not just on a nominal basis, but on a real basis as well. And real rising prices do put pressure on consumers to maybe thrift if these rise too high. However, that also means that the marginal project of yesterday is now more in the money than it was before. So there's some good and some bad when it comes to looking way out into the future. But over these next few years, we'll have to be cautious in how we present our story to financiers, how we present that this is a long-term issue, and that if we don't start now, we will never catch up. There's just no doubt about that. So looking at pricing. Over the last couple years, we've seen significant growth in pricing for lithium, for cobalt, for aluminium, and for nickel. And we saw that over the last 2 years, including for lithium. And it goes off the chart here, actually, to about 300%. But I didn't want to screw up the scale too much. So it's well over 100% there, and I did not put my marker on it, so I'll make sure that that gets in the presentation later. But we can see here into 2023 and 24 that some pricing is going to moderate. Cobalt was down so much in 22, 23, it's already coming down, but it will bounce back, and then there will be some moderation of that growth. For lithium and nickel, we're certainly going to see some slowdown in that, some softening, but it's not going to crash. These are markets that are becoming slightly more mature. For lithium, if you put it in person terms, they probably have some pockmarks on their face. They're a bit of a teenager. With vanadium, it's a bit of a toddler. So there are going to be some raising challenges there for those parents out there. And so some of these things are going to have to go through some dips, some valleys along the way. But well-costed projects with good engineering can certainly weather this and can still present and come to market. But it takes a long time. And no matter where you start that first bit of the feasibility study, like Robin said, you have to weather 7 years of ups and downs in terms of pricing before you even produce your first ton. So that can be quite difficult to weather. But without crashes and without peaks and valleys, markets don't really have much interest, do they? Mm-hmm. So we move on to this. Something that really is an important challenge for the market is going to be power availability and the needs of power. So we can see here, copper is an enormous market, but in general requires far less megawatt hours per ton of material produced. And that's because, at the mine site, you're using more diesel and things like that. Certainly, you will be moving more towards electrification even at the mine site, and many mines are already doing that. But if we look at the upper left-hand part of this chart, these are some pretty critical minerals here that are going to require a significant amount of new power. Silicon's probably the one that has the most, because silicon, like aluminium, is literally solid power. And wherever you see a silicon smelter, it is most likely that it has cheap and available power. Finding cheap and available power that is low carbon will certainly be a major step for any new silicon producer coming into the market. And we need approximately 4 times as much silicon by 2050 as we do today. So that's going to be a lot of silicon plants. So we have about a 1.3 million ton silicon market today. It needs to get to about 4.5. Every silicon plant in the world is about 50,000 tons. So it doesn't take a whole lot of hard math to figure that out, that we're going to need a lot of new plants. And they have a difficulty in getting completely carbon neutral because you absolutely need a carbon reductant into the production of silicon, and you need wood chips that will also be burned in this. So there's always going to be some last mile of emissions that need to be covered from different solutions, whether that be carbon capture, utilization, and storage, or other solutions around that to mitigate this carbon. However, it's not going to leave the production process. So there are challenges here in terms of making the emissions lower, but also just finding power to put these silicon smelters together. There are other challenges, of course, around raw materials and so far, but we will work on that in just another slide. So truly, there are many more barriers to the production of these materials other than money, though money is clearly the first one. So we have all these macro goals. We have macro problems. We all want to reach the Paris agreements, but it's going to take a lot of on-the-ground practical solutions. This isn't going to be a silver bullet that gets us here. It's a silver shotgun. And there's no doubt about it. It's going to be a lot of on-the-ground solutions where we have to work with local authorities to build roads as junior miners. We have to find solutions to getting good power, to getting reliable power that is low emissions, so that today, when your mine is presented to financiers, you can show a low emissions picture. Because not only cost, but also emissions becomes a play. As we look out into the 2030s and carbon becomes priced in many areas, especially with CBAM and other schemes that have come along, that's going to be increasingly important to the actual cost of your production and how it is compared with other producers in the market. So yes, we're going to need an accelerated growth. We need a lot of that, but mining shareholders want reliable profitability. There's no doubt about that. Anyone who's involved in that wants to make money. This isn't a charity here. Maybe one day UNICEF comes along and starts making lithium, and we're all out of business. Fine. If that day comes, I'll be the one buying beer, okay? But there's going to be a bunch of mismatches here. Technology uncertainty. Which technology is going to win out? We can look out to 2050 and we can predict all of the battery metals that are needed, as Robin rightly did, and he was quite right. But what happens if technology moves more quickly than production? If production of materials takes so long and is so costly that truly another type of battery, another type of drive comes in. It's possible. We are talking 27 years in the future, and most cars take about 5 years. In 10 years, you could see changes. So that's certainly going to be part of it. The timing of supply versus demand. As EV penetration numbers rise quite quickly, that is a clear indication that more battery metals are needed. But if that softens and your mine comes on right at the wrong time, that can be quite a difficult proposition in terms of getting your profitability for yourselves, for your financiers, for anyone else. The traditional due diligence process has become quite a bit different. Markets like vanadium, lithium, nickel used to be very reliable. Lithium used to grow exceedingly close to industrial production numbers because it was almost always used in industrial uses. That's not the case anymore. So the traditional due diligence process now requires some agile thinking from both the financiers and those presenting their cases. We will be seeing a lot more local solutions, and I think that's the key right here in South Africa, throughout South America, throughout every other jurisdiction that actually does true mining, that the local solutions will have to be there. We spoke a lot yesterday and listened to a lot of presenters saying these things need to be fixed. Well, it's going to need to be fixed right now, okay? And it has to be done locally. It can't be done at a global level. You can't change mining policy at a global level, but you can set global targets. And of course, power availability and risk appetite I've already spoken about. It's the risk appetite for some of these financiers. They see the numbers in the future and they say, oh, this looks great, but if this doesn't go well, we could lose our shirt. And no one wants to see that. So it's an appetite to go into markets and to the jurisdictions that they have not gone before, ones that maybe have a reputation which is still, deserved, and some of which are changing. And it's those changing ones that there has to be some appetite for risk, to dive in there, to put some money where your mouth is, and to actually come forward with some of these projects. But this is the big one here, and I love this slide. Playing catch-up early means greater risk down the line. So this is in gigatons of CO2. On our top line here, this is pretty much what we're looking at, folks. Emissions are going to rise because what's going on right now is more industrialization, more coal-fired plants. There's a great question actually in the Q&A there about what is the impact of new coal-fired power stations in places like India and China? Right there, right there. So getting down this steep slope then requires that money that Robin spoke about to come on faster, to come in an unprecedented rate, even more so than if we started today. Well, and we're not starting today, because this is what it would look like if we actually started today, or we really got ahead of ourselves. And if we were coming along down this line, you can see that then it becomes much easier to meet these goals by 2050. However, that's really not what is happening right now. So this acceleration is now going to be truncated. Instead of being 30 years, now it's 27 years, 26 years, 25 years. Well, the number of $27 billion per annum in copper starts to rise year by year and becomes even harder to achieve, especially when money is getting more difficult to obtain. So if there are jurisdictions that are willing and able to provide first mover advantages, they're going to win out here because production in the market is going to be trumping what is not in the market. However, it's like a fire drill. You have about 30 guys running for one door. Not everyone's going to get in, but the rewards for getting in are far greater than for not trying. So this is, of course, speaking about silicon again, there are general issues across every industry, but silicon's a pretty big one because raw materials for silicon are kind of difficult to come by. So a good one is quartz. So lumpy quartz is required to produce silicon metal. You don't go looking for lumpy quartz. You kind of find it when you're looking for other things. So that's not exactly a great exploration technique, regardless of whatever your policy is around exploration. If you just happen upon it, that's not going to be very good. And by 2027, we need another 1 million tons of lumpy quartz. That's very difficult to find and has to come from far away. There's a large amount of folks in Saudi that would like to put on a silicon smelter. Many different companies are looking into this. And Saudi's covered with sand. but no lumpy quartz. They can make ferrosilicon, but they can't make silicon metal. They also don't have the available wood chips. If you go to Saudi, there's not a whole lot of trees. So these are imported items of actually low value, but high importance to the smelter. So it becomes a difficult game to play of how much does the price need to rise because of costs rising. And that's not even to speak about the major input to any silicon smelter being power. So it's the scale of capacity needed, it is the timing, and it's really it's a chicken and the egg problem. If the demand isn't there today, how can you finance on this? You have to believe in the story of the future. And this has to be believable both from a standpoint of demand, but also that emissions will continue to be important. But local ESG challenges really don't often align with the long-term goals from the Paris Agreement. Because local goals are around not polluting my water, having my water, those type of things. It's about having safe jobs there. It's about being a responsible steward after the mine is finished. These are local questions, but they need to be solved as badly as the global questions need to be solved as well. So this has to be in lockstep a little bit. However, it has to be going on in sort of parallel tracks. And the emissions that are needed, the emissions that will go on from many of these will be quite high. I really like the nickel one because for HPAL plants, you need 25 tons of sulfuric acid per ton of nickel, give or take. That's a lot of acid. That's a lot of burnt sulfur in this world. It's a lot of sulfur that now needs to be transported really to Indonesia where they're short on sulfur. There's a lot of places like that. And sulfur burners are one of the hottest new plants that come online. Everyone needs the steam, the power, the other benefits from this. However, it's going to be a lot of acid that goes on out there. There's going to be a lot of disposal of wastewater. All of this has to be solved for each and every operation. And each one is in a different place with different specific issues, even if you're in the same jurisdiction. So these aren't going to be easy problems to solve, and they'll have to be very much up to the individual junior miner and the individual authorities on the ground. That's a lot of different players that everyone has to dance to the same tune. And I don't know if you've ever been to a party. I've seen some bad dancers out there, okay? So we've got specific short-term solutions are needed to achieve these long-term goals. The first is you have to quantify the problems. Wherever you want to intervene, you have to know what that math is. You have to know the expectation of the future pricing, the expectation around future emissions costs, and what you can do about that. You got to pick your fight as well. You can't do everything in a day. So what are the things that have the most impact with the least work? Ranking those and having a quantifiable portion and what it's going to cost you and what it's going to cost investors is very clear. And then for this, once you've picked your fight and you know what it's going to cost, you have to have targeted solutions. This will be streamlining processes. This is working with engineers to make sure that you have the most efficient process possible, one that can come online without a terrible amount of ramp-up issues. Though I really haven't seen a whole lot of companies that have met exactly their ramp-up goals, but I wish them luck. You need to build the bridges yourselves between the local and global stakeholders, knowing that, hey, we want to get here and we can convince the local authorities that the global goals are valid. But how does that fit into what you're doing on the ground? And finally, we need to selectively assume and share the risks. You can't take on everything, just like picking a fight. There's some risk that can't be mitigated, but that may be the same for you as it is for your competitors. And that's okay. But you have to take on these risks. You have to take on these challenges. For any of you Star Trek fans out there, ESG is a bit like the Borg, okay? Their resistance is futile. So you have to keep going on this. You have to find really the ability to take on these risks and push forward. And with that, that's me. So thank you all for paying attention. Appreciate you.
Thank you. Thank you, Willis. I am going to have to rewatch both of these recordings a few times to pretend to absorb the depth and the breadth of the topic. I've looked at all the presentations that will be made today and yesterday. And when we come to junior miners, we hear all of the stuff that we say, fantastic time, prices are going to go through the roof. Mm-hmm. You calling bullshit on that?
For the next few years, yeah.
Yeah, you're calling like the foreseeable future, the time in which we need to raise the money. Mm-hmm. Perhaps the bubble or the spectacular times are behind us in some commodities. The next few years are going to be tough to tell a positive story and look at the spot price. Am I interpreting all of this correctly?
Absolutely. It's a harder story to sell. If prices are at peak levels, much, much easier to sell your story to bankers, financiers, private equity.
Well, we failed then
Yes.
in the last 2 years, so we didn't raise the money, and it's going to be harder going forward.
Exactly. And of course, spikes don't make anyone happy. You
Yeah.
can look at any of these price charts in the history of it. No financier wants to see this price going up and down like they do. But again, some of these markets are going to become more mature, and some softening is part of that.
Robin, can I ask you, there were questions in the Q&A section about PGMs. Now, we do a hydrogen day, and I'm unconvinced in my own mind about where hydrogen is playing out. Obviously, as a platinum-producing country, we almost need the hydrogen story to have substance. Because
almost. You absolutely do.
But that doesn't make it true, just because we need it to be true. So, I don't know, Robin, do you want to comment at all on PGMs broadly, and then I'll come back to Willis?
Yeah, can you hear me?
Yes, indeed. Please proceed.
Oh, you can. Yeah, sure. Yeah, well, let me say something very simple. I mean, we don't cover PGMs from a market's perspective, but we're obviously looking at the demand that's going into to electrolyzers, and it's a fundamental driver of how quickly we think electrolyzer capacity is going to be rolled out, and that is obviously in turn very important determinant in how quickly costs and prices for hydrogen can fall and become competitive. So there's a lot of concern given the 90% odd control of supply that's coming out of South Africa. I mean, Russia and Canada do a little bit, but I mean it's a major worry in terms of how quickly. So I mean, we do have a very aggressive cost reduction for hydrogen production over time, and it does start to allow penetration into the sort of power space and also vehicles, but and also hard to abate sectors like steel. But we're looking at a 2035 plus period, if I'm talking about steel, before you really start to see any sort of meaningful penetration. And there's a lot of arguments about what the price of hydrogen needs to be. But even if you're at $2 a kilo, which is kind of the first stage that people are talking about, you've still got a steel product that is much more expensive than a Chinese blast furnace, BOF. So there are big questions about how quickly it's going to be able to penetrate into Asia, which are the markets, of course, that are going to be absolutely critical to getting the energy transition on track.
Thank you.
I mean, I think PGMs are in a difficult position today because they're relying on one horse in the future, and all the horses today are not running very fast, and some of them are going to be declining. Having recently done this, it's quite a discussion. And as EVs penetrate more, the current demand for PGMs it's kind of the same story. It's going to be difficulty now, but you need more in the future. So how do you sell that story to someone who's looking at the market and saying, well, what if this doesn't happen? What is that appetite for risk to even finance new projects, to bring old mines back into production? Quite a few, pits out there, but bringing them back on is not easy. And especially as some of these pits have been closed for quite a while, getting the workers, having even just the talented workers. Look at all of these. The growth that's going to happen here means that you're going to need twice as many operators as you had before because the market's twice as big. Where do you get them? We have to train them. That's not easy. Finding reliable operators, I think, is going to be an absolute difficult problem. And brownfield sites are one of the hardest because some of the people are dead to be able to run the machine. So how do you get these back online? It's definitely going to be one of the many challenges here.
I want to quickly go to Tawfiq is bold enough to say what a lot of people probably feel. Cumulatively, Africa has contributed less than 5% of global CO2 emissions. should Paris targets drive Africa's socio-economic development goals? Can't we just be allowed to pollute a little bit longer whilst you bloody Europeans and Americans sort out the world?
You know, it certainly would be a great thing if we could. I'd love to allow that, but as not a politician myself, it's pretty difficult there.
It's not likely either. Yeah.
Exactly, but I think the other way you can spin that is Africa will benefit from the dirtiness of the rest of the world. So you can spin it the other way, and that the energy transition is going to mean a lot for Africa. And even if it doesn't mean that there's going to be roses for everyone, it's certainly going to be a driver of significant mineral development growth here, and hopefully eventually more processing and true demand for these minerals in Africa as well as Africa develops.
You see, I'm going to capture that. I'm going to put it through ChatGPT, and it's going to be my opening speech at the London Indaba when we talk about the benefits for Africa out of this coming transition. So we can take a victim stance, or we can take a more positive stance and say, what are the opportunities for us as a continent in
You can be the victim in your own story, the martyr, or the hero, and I prefer to be the hero.
There is a question, and this doesn't come from me. If there's anybody from Steenkamp in this audience, it can only come from them. What is the role nuclear power and the revival of thorium reactors, which seems to resolve many of nuclear problem issues? Now, this is minute detail of a very specific area. You want to give a short answer to that?
Where it's going to, I think, have the most impact is aluminium. So aluminium right now is essentially solid power as well. And the difficulty in changing or moving a smelter is pretty much impossible. So you have to change the power. A lot of aluminum smelters today are looking upstream. They're putting pressure on their bauxite miners and their alumina suppliers to lower their emissions because they can't do much about their own. A nuclear reactor that you could put in, one that solves some of those issues, and especially one that's a little bit smaller, maybe specifically just for a plant, actually provides quite a unique solution and may allow for a lot of the aluminium smelters that were looking into inert anodes to scrap that and allow that just to be carbon capture and storage, because that ends up being the last mile. So this could have a quite significant impact on both aluminium and on silicon smelters. So anything that really requires that type of power and can't change their own, especially older ones. I mean, there are silicon smelters that were built in the Second World War that are still operating.
Yeah. Robin, final comment from your side. Firstly, thank you very much for making yourself and your company's intellectual property available to us without any warning clauses. Any final comments from you in wrapping us up?
No, thank you very much. I did have a disclaimer. I didn't show you it. It'll be in the PDF. No, I was just going to add, I mean, the opportunity for Africa, I mean, one of the things, I mean, it does feel a little bit wrong when we talk about the opportunity for Africa, just thinking about what Africa might be able to do for the rest of the world and them meeting their targets when Africa has its own targets that it wants to meet. But it does feel like a wonderful opportunity. I mean, particularly as we're trying to diversify supply chains from China. I mean, theoretically at least, it's an opportunity for Africa to stand up. So I think particularly when you look at Chile and Peru and some of the issues around Panama, all of the problems around community support that there are around the world, Africa looks pretty good. So I think there's plenty of reason to sort of move forward with confidence.
No, thank you very much, sir. So you look like you want to have a final say.
Just be the hero.
Thank you very much to both of you. What we spoke about here was like big picture, demand, the supply side, some good statements about, of course, that gap doesn't really exist. It clears out in the pricing. And I do want to comment that one of my favorite presentations to come is from MMC, partly because I'm the chairman of MMC, which speaks to this micro space of manganese metal making and manganese sulfate making, because in this value chain, there are multiple players, and each one of those has to be capacitated, funded, brought on stream, priced correctly. The world has to get this wrong until we get it right. So it's going to be a fantastic journey for those of us in this space. Gentlemen, it was really mind-blowing. I'm not allowed to swear again. Somebody pumped me to my wife, who sent me a WhatsApp, so I'm already in trouble. But it was really a mind-blowing inputs from the both of you. Thank you very much. I really appreciate it. Thank you.
Thank you very much.
So he's not here because they are the lead sponsors. He's here because he is positioned to speak to the topic of, can we actually still build these world-class mines? Just not in my backyard, okay? Not in my Europe, in your Africa, or whatever.